Here we have a table and they're asking us to figure out, is this a linear function or not? And the way we're going to do that in the table format, I like it because what you're going to do is just evaluate the x values and you're going to check, okay, to get from this number to this number, how much did it change by? Well, from -4 to -2, I would have to add 2 to -4 to give me this number. So it changed by 2. In other words, it increased by 2. And then I check the next setup. From here to here, I can see it increased by 2 again, right? -2 plus 2 is 0. And then from here to here, it increased by 2 again. So it went from 0 to 2, right? 0 plus 2 is 2. So we have a constant rate of change for all the x values. And now, to see if it's a linear function, we're going to check, is there a constant rate of change for the y values now? So for the y values, I can see from here to here, it decreased by 2. So it went down 2, right? 3 minus 2 is 1. Next, from 1 to 1, it changed by 0. So it basically increased by nothing, right? We have an increase of 0, stayed the same. And then from here to here, it increased by 2. So notice that it decreased by 2, stayed the same, right? It increased by nothing, it didn't change. And then it increased by 2. So we don't have a constant rate of change. And a constant rate of change means it should be the same value. So in this case, it was a constant rate of change because it added 2 every time. Here, it's not the same value, it's different. So if your values are different, automatically it's not going to be a linear function, or it's not a linear function. And keep in mind that a linear function just means if you were to graph it, I want you to see something. So I'm going to plot those points. So we have -4, 3. So I'm going to plot those. -1, 2, 3, 4. So -4, 3 would be right here. Then we're going to plot the point -2, 1. So -2, 1 will be right here. Then we have to plot the point 0, 1, which would be up here. And then we're also going to plot the point 2, 3. So 2, 3 will be somewhere here. So it's a quick sketch. But you can see here, look, if I were to connect these dots, you can see that it's not a straight line. And that's what they mean by linear function. If you graph it, you want something that is a straight line, is linear. It's a straight line. So the word linear, if you look at the word linear itself, right, it has the word line in it. So it should be a straight line. And that's what we're looking for. It says we don't have a straight line, not linear. And again, you'll be able to tell without graphing it by looking at the constant rate of change for the x's and the y's. This should always be the same, and this should always be the same. Again, these don't have to be the same as each other. As long as it's the same for the x's, and as long as it's the same for the y's, it'll be linear. And that's why this is not a linear function.